The thermal insulation design of the building is carried out according to the minimum requirements of the thermal engineering design of the building envelope. The minimum requirements for thermal design are as follows. 1. No condensation should be allowed on the inner surface. That is, the inner surface temperature of the outer protective structure should not be lower than the dew point temperature of the indoor air, so as to avoid mildew on the wall. 2. Civil buildings need to meet certain thermal comfort conditions and avoid excessive cold radiation effects by limiting the inner surface temperature. 3. From the perspective of NGCV, reduce heat loss as much as possible. 4. The room needs to have a certain thermal stability, and the heat storage of the envelope structure is used to achieve this requirement. Think about it. Which requirement is the lowest? The first one is a requirement from the perspective of height and housing quality, and the others are requirements from the perspectives of thermal comfort, NGCV, and room temperature stability respectively. Therefore, the first one is the most important and basic requirement. According to the thermal design specifications of civil buildings, the benchmark conditions for thermal insulation design calculation are determined as cold weather according to the most unfavorable conditions. This is the distribution of outdoor temperature in winter on cloudy and sunny days. It can be clearly seen from the figure that the outdoor temperature in sunny days has a large fluctuation, while the outdoor temperature in cloudy days is very stable. This is because the cloudy days are not affected by solar radiation, so the heat transfer of the enclosure structure can be calculated according to the steady heat transfer. From the calculation method of steady heat transfer, it can be known that the heat transfer resistance can be used as a characteristic index to describe the thermal insulation performance of the envelope structure. It can be concluded that the method of building thermal insulation design is a minimum heat transfer resistance method, which ensures the thermal performance of the envelope structure by limiting the minimum heat transfer resistance. The calculation formula of the minimum heat transfer resistance is the minimum standard of thermal insulation design. When selecting the outer protective structure, it must be greater than the calculation result. When the outer wall adopts lightweight materials, or the inner side adopts composite lightweight materials, additional corrections should be made. Ri the heat transfer resistance of the inner surface, which is generally taken as 0.11, and the temperature difference correction factor, which can be obtained from the table according to different parts of the enclosure. When the outer surface of the enclosure is not in direct contact with the outdoor air, it needs to be corrected. This is because the calculation formula of the minimum heat transfer resistance uses outdoor air temperature, such as 0.3 for expansive zones and 0.9 for roofs with ventilation air layers. Ti is calculated indoor temperature in winter, and it is taken according to the functions of the room. It can be taken as 18 degrees Celsius for general residential buildings, and 20 or 22 degrees Celsius for rooms with high comfort requirements. T is the calculated outdoor temperature in winter, which is valued according to the thermal inertial index. The thermal inertial index is divided into 4 ranges, and the thermal inertial index decreases in turn, respectively for Type 1, Type 2, Type 3, and Type 4 buildings, of which Type 1 and Type 2 buildings are heavy buildings, and Type 3 and 4 buildings are light buildings. The calculated outdoor temperature of different building types at the same location is different. The calculated outdoor temperature of Type 1 building equal to the calculated outdoor temperature of heating, which is equivalent to the average daily temperature that have 5 days per year without guaranteed to meet the target. The calculated outdoor temperature of Type 4 buildings equal to the lowest daily average temperature over the years. The calculated outdoor temperature of Type 2 and 3 buildings needs to be determined by calculation. It can be seen from this table that when the thermal inertial index is large, the calculated outdoor temperature value is high. This is because the thermal insulation design is calculated based on steady heat transfer, assuming that the indoor and outdoor temperatures do not vary with time change, but in fact both of them change. Because different envelope structures have different resistance to temperature change, the same temperature change has different effects on the inner surface temperature of the envelope structure. For heavy structures, such as concrete, the impact is small, and the impact on the lightweight structure is large. Delta is a allowable temperature difference between the indoor air and the inner surface of the internal envelope, and it is considered to avoid condensation, excessive cold radiation, and excessive heat loss. The thermal performance of the enclosure structure can be tested by using the calculation formula of the minimum heat transfer resistance. For the new building, the form of the external enclosure structure needs to be reselected if it is not satisfied. For the existing building, the insulation layer needs to be added if it is not satisfied. The insulation thickness can be determined by calculation. Next, let's do an exercise. Taking Xi'an as an example, the outdoor calculation temperatures in winter for type 1, 2, 3, and 4 buildings are -5, -8, -10, and -12 degrees Celsius respectively, and the indoor calculation temperature is equal to 18 degrees Celsius. Please verify whether the external wall of a residential building meets the thermal requirements. Let's analyze the finger first. From the finger, we can see that the external wall is a solid brick wall with two layers, inside on the left, outside on the right. According to the numbering method of winter steady heat transfer calculation, the numbering method is along the arrow direction of heat transfer, which is marked as layer 1 and 2 from left to right. The internal plastering layer is like model with a thickness of 20 mm, and the thermal conductivity and thermal storage coefficient are 0.81 and 10.12 respectively by looking up the table. The thickness of brick masonry is 240 mm, and the thermal conductivity and thermal storage coefficient are 0.76 and 10.16 respectively by looking up the table. The solution to this problem is as follows. First, the thermal resistance and thermal inertial index of each layer are calculated respectively, and the comprehensive heat transfer resistance and thermal inertial index of brick walls are obtained through summary. According to the thermal inertial index, the outdoor calculation temperature is determined, and then the minimum heat transfer resistance that should be reached is calculated. The comprehensive heat transfer resistance and the minimum heat transfer resistance are compared. If the comprehensive heat transfer resistance is greater than or equal to the minimum heat transfer resistance, it indicates that it meets the requirements of thermal engineering design. Otherwise, it does not meet the requirements, and it is necessary to increase the insulation or redesign the envelope structure. First, according to the calculation formula of thermal resistance, R0 is equal to R1 plus R2 plus Ri plus Re equals 0.49. And then according to the calculation formula of thermal inertial index, D0 equals D1 plus D2 equals 3.464, the value between 1.6 and 4. It should be the type 3 structure, and the outdoor calculation temperature is -10 degrees Celsius. But the thermal design code stipulates that when the solid brick wall D less than or equal to 6, Te is taken as a type 2 value, so the outdoor calculation temperature is calculated according to the type 2 -8 degrees Celsius. Then take delta as 3 degrees Celsius according to the residence and external wall, According to the calculation formula of the minimum heat transfer resistance, it is found that R0.min is equal to 0.883 compared with comprehensive heat transfer resistance 0.49 that previously be obtained. The results show that the volume does not meet the thermal requirements. You can do the thermal performance verification calculation for the building's design work according to the above method. You can also try to change the solid bricks to hollow bricks or change the thickness of the wall. You can also think about what to do if the calculation results are not satisfied. What kind of insulation foam is used? If a single insulation layer is used, how thick should the insulation layer be? Is the insulation on the inside or on the outside?